Hello everyone, welcome back to our channel. This is second lecture on differentiation. In this lecture we are going to study derivatives using first principle. Derivative of a function at any point. I would suggest you to note down all the notes in your notebook. If limit h tending to 0, f of a plus h minus f of a upon h. If this limit exists, okay, the limit has to exist. If this limit exists, then it is called as derivative of f of x with respect to x. Limit h tending to 0, f of a plus h minus f of a upon h. If the limit exists, then it is called as derivative of f of x with respect to x. At what point? Guess at what point? Any point? At a point a. Okay, so it will be denoted by what? F dash of a. So I can say that f dash of a is equal to limit h tending to 0, f of a plus h minus f of a upon h. Now we know that f dash of a exists in this case. Okay, so the function is said to be derivable. The function is said to be which function? F of x. The function is said to be derivable or differentiable. The function is said to be derivable or differentiable at point a. So in general, if I want to write, in general I can say that f is differentiable with respect to x. F is said to be differentiable with respect to x, and it will be denoted by f dash of x. Therefore, I can say that f dash of x equals to limit h tending to 0, f of x plus h minus f of x upon h. I repeat, in general I can say that f dash of x equals to limit h tending to 0, f of x plus h minus f of x upon h. What is f dash of x? That is derivative of f of x. This is known as first principle of derivatives. It is called first principle of derivatives. If the limit exists, which limit? Limit h tending to 0, f of x plus h minus f of x upon h. If the limit exists, then this limit is called as derivative of f of x denoted by f dash of x. This is called first principle of derivative. Okay, so we are going to solve some problems based on this. Let's start. I suggest you again copy the notes, copy the problems. Once the explanation is done, you can pause the video, note down the problem. Okay, let's start. The question is, find the derivatives by first principle. Find the derivatives by first principle. So what's the important part in this question? First principle. So let's start. Number 1. 3x squared plus 4. In this case, what is the function? F of x is 3x squared plus 4. Just to remind you again, what is f dash x? Using first principle, limit x tending to 0, f of x plus h minus f of x upon h. So before you find derivatives using first principle, I need two things. One is f of x plus h, second is f of x, and then in the question f of x is already given. So first we'll find f of x plus h. So if you see, you have to just replace x with x plus h. Okay. Question is, the function is 3x squared plus 4. So instead of x, I will write x plus h whole square plus 4. So we are just replacing x with x plus h so that we can get the value of f of x plus h. Now let's simplify this. X plus h whole square, a plus b whole square, a square plus 2ab plus b square plus 4. Just simplify this. So what do we get? 3x square plus 6xh plus 3h square plus 4. So now we have got our material. What is that? F of x plus h. So we have f of x, we have f of x plus h. Now to find derivative, what do we need? The derivative is given by f dash of x. What is that? Limit h tending to 0, f of x plus h minus f of x upon h. So limit h tends to 0. What is the value of f of x plus h? Look over here. That is 3x square plus 6xh plus 3h square plus 4 minus f of x. What is f of x? 3x square plus 4 whole thing divided by h. So what we need to do, we have to eliminate this h. Okay, why? Because anything divided by 0 is not defined, so we'll try to eliminate h. So let's simplify it further. Limit h tending to 0, 3x square plus 6xh plus 3h square plus 4. So when you open up the brackets, it becomes minus 3x square minus 4 whole thing divided by h. 3x square minus 3x square plus 4 minus 4. What are we left with? Limit h tending to 0, 6xh plus 3h square upon h. Okay. Now in the numerator, if you observe, I have a common factor. What is that? Take h common. What is left? 6x plus 3h whole thing divided by h. Can cancel h. So h got eliminated. We are left with limit h tending to 0, 6x plus 3h When you apply limit, you take the value of h as 0, so this will be 6x plus 3 into 0. So what's the answer? 6x. So what's the derivative we have got? 6x. Using first principle of derivatives. Let us solve the next question. Question number 2. F of x is 1 upon 2x plus 3. So first let's write this first principle. F dash of x equals to limit h tending to 0 f of x plus h minus f of x upon h. So before you begin with the first principle, you need to know the value of f of x and f of x plus h. We have f of x, so using this we'll try to get the value of f of x plus h. So what will be that? Just replace x with x plus h, 2 into x plus h plus 3. So what is that? 1 upon 2x plus 2h plus 3. So now let's start with f dash of x. What is f dash of x? Limit h tending to 0 f of x plus h minus f of x upon h. Just put the value of f of x plus h. So what do we get? Limit h tending to 0 1 upon 2x plus 2h plus 3 minus 1 upon 2x plus 3 whole thing divided by h. Again, we'll try to eliminate that h in the denominator. So limit h tending to 0. For timing, I'll take that 1 upon h aside. So we are left with 1 upon 2x plus 2h plus 3 minus upon 2x plus 3. So what do we get? Limit h tending to 0, 1 upon h. Just simple cross multiplication will give you 2x plus 3 minus 2x minus 2h minus 3 divided by 2x plus 2h plus 3 into 2x plus 3. Simplifying it further, what do we get? 2x minus 2x plus 3 minus 3. So we are left with limit h tending to 0 1 upon h multiplied by minus 2h upon 2x plus 2h plus 3 into 2x plus 3. H gets eliminated. Okay. So limit h tending to 0 minus 2 upon 2x plus 2h plus 3 into 2x plus 3. Applying the limit gives minus 2 upon 2x plus 0 plus 3 into 2x plus 3. That is minus 2 upon 2x plus 3, the whole square. That's it. So, in the first principle, we have limit h tending to 0, f of x plus h minus f of x upon h. We know that anything divided by 0 is not defined. So, in first principle, we will try to eliminate h in the denominator. That's it for today. In the next class, we'll solve more problems based on first principle of derivatives. Like, comment and subscribe to the channel so that you don't miss any of my future videos. Thank you.